Hey everyone, I hope you all are doing well. My name is Sakshi Saxena and I'm a GDSC technical team member and your Google Cloud Facilitator. I welcome you all to our third Cloud Study Jam for the 30 days of Google Cloud program. If you haven't watched our previous sessions, I would highly encourage you all to go to YouTube and watch them. Let's see what we have for today. Today we'll be discussing about the introduction to Track 2 and introduction to AI. Then we'll move on to discuss the applications and uses of AI and ML in GCP. Then we'll be seeing the platform setup and we'll be doing a one hands-on lab. And then we'll be discussing about the doubt sessions that are going to happen on every Tuesday 6 p.m. So to start with the definition, what is machine learning or ML? ML is a way to get productive insights from data to make repetitive decisions. You do this using algorithms that are relatively general and applicable to a wide variety of datasets. Now, think of a typical company and how they use their data today. Perhaps they have a dashboard that business analysts and decision makers view on a daily basis. Perhaps a report that they read on a monthly basis. That's an example of backward looking use of data. Looking at historical data to create reports and dashboards. This is what people tend to mean when they talk about business intelligence. A lot of data analytics is backward looking. Instead, we will use ML to generate forward looking or predictive insights. Of course, the point of looking at historical data might be to some make good decisions. Perhaps business analysts examine the data and suggest new policies or rules. They suggest, for example, that it might be possible to raise the price of a product in a certain region. Now, the business analyst is making a productive insight. But is that scalable? Can the business analyst make such a decision for every product in every region? Can they dynamically adjust the price every second? In order to make such decisions around predictive insights repetitively, you need machine learning. You need a computer programming deriving such insights. So, ML is about making many productive decisions from data. It's about scaling up business intelligence and decision making. Now, ML AI for every level of expertise. We see that the Google Cloud's AI Hub is a repository of plug-and-play AI components, including end-to-end AI pipelines and out-of-the-box algorithms. AI Hub provides enterprise-grade sharing capabilities that let organizations privately host their AI content to foster reuse and collaboration among machine learning developers and users internally. The building blocks. APIs, AutoML are machine learning APIs let you access pre-trained models with a single REST API request. So, you need not do any data training. You want to accomplish a common ML task. This is great to use. AutoML also allows you to have custom models customized to your dataset. You can train and serve your own models. No model code is required, so no code needed to set up the model. For the built-in tools, we have AI Platform Notebooks. So AI Platform Notebooks is a managed service that offers an integrated Jupyter Lab environment that comes pre-installed with the latest data in science and machine learning frameworks in a single click. AI Platform Training and Prediction. AI Platform Training and Prediction is a managed service that enables you to easily build machine learning models with a powerful TensorFlow framework. It provides scalable training and prediction services that work on a larger scale datasets. This abstracts away some of the manual work around scaling and training of data and allows you to have a managed service to take care of that for you. Now, what is deep learning VM images? These are pre-packed virtual machine images that have machine learning libraries installed on them already. So, you don't need to have installed them by hand. And additionally, if you want to add things like GPUs to that instance, you don't need to worry about installing the drivers to power those GPUs. Then we have Qflow, which is an open source project created by Google that lets you deploy machine learning pipelines on Kubernetes containers. And Qflow has this concept of components. So you can break your pipeline up into individual components for pre-processing data, training, and serving. So all this is created with BigQuery, Dataflow, etc. This is on a strong infrastructure foundation with TPUs, GPUs, and frameworks you are already familiar with, like TensorFlow, Keras, PyTorch, and Spark. ML uses standard algorithms to derive predictive insights from data and make repetitive decisions. By this, I mean that ML uses standard algorithms to solve seemingly different problems. Normally, when we think of computers, we think of programs that do different things. For example, the software that we use to file our taxes is very different from that we use to get to home to directions. Machine learning is different. We use the same software. That's what we mean when we say ML uses standard algorithms. But we can train that software to do very different things. We can train that software to estimate the tasks we owe, or we can train the software to estimate the time it will take us to get home. The MLAI software once trained is termed a model. So we now have a model that can estimate taxes, or a model that can estimate the time to get home. We can use the term model because it is an approximation or model of reality. For example, we are giving the computer lots of historical data on drive times in New York City, and it will learn the relationships in the data, like traffic patterns, seasonality, time of day, to predict today's commute time home. So whatever the domain may be, ML model training requires examples. So we'll train the model to estimate tax by showing it many examples of tax returns. We'll train the model to estimate trip duration by showing it many journeys. The first stage of ML is to train an ML model with examples. The firstly, you might be asking yourself, isn't the logic different? But no. You cannot possibly use the same rules or values identifying defects in manufacturing that you don't do in underlying leaves. The logic is different, but ML doesn't use logical rules. With that, I mean that the image classification network isn't a set of rules, like if this then that, but a function that learns how to distinguish between categories of images. So, even though we start with the same standard algorithm, after training, the trained model that classifies leaves is different from the trained model that classifies paths. And guess what? We can actually reuse the same code for other use cases focused on the same kind of task. So, in our example, we were identifying manufacturing defects, but the higher level task can classify images. We can reuse the same code for another image classification problem, like finding examples of products and photos posted on the social media. However, we still have to train it separately for each of the use cases. So now it's time for the hands-on session. So if you haven't watched our Cloud Study Jam session 2, you can click on this link on the Linktree GDSC Banasthali Vidyapith and watch the second session. Now moving further with the hands-on lab, go to the fourth tab on the Linktree that says 30 days of Google Cloud tracks and syllabus, and then we'll go to the program syllabus. Today we'll be covering the track 2. Many of you have covered the track 1 and it's time for us to dive into the track 2. So we'll be taking up the second skill batch today, that is perform foundational data ML and AI task in Google Cloud. So let's see what we have to do in this skill batch. We'll be completing the perform foundational data ML and AI task quest, where you'll learn the basics features for the following machine learning and AI technologies like BigQuery, Cloud Speech AI, Cloud Natural Language API, AI Platform, Dataflow, Cloud Data Prep, and Video Intelligence API. So for this, we need to enroll in this quest. So firstly, we will click on this blue button that says enroll in this quest. And then we'll sign in with our Google account. enter your credentials. Send next. Then we'll add our password. Now, we'll perform today the very first lab, that is AI platform quick start. Let's see what we have in this lab. So this lab is going to give you a hands-on practice with TensorFlow 2.x model training, both locally and on the AI platform. After the training, you will learn how to deploy a model to AI platform for serving prediction. You'll train your model to predict income category of a person using the United States Census income dataset. So this lab is going to be an introductory lab and is going to be an end-to-end experience of training and prediction on AI platform. This lab will be a census data to create a TensorFlow 2.x training applications and validate it locally. Run your training job on a single worker instance in the cloud. Deploy a model to support prediction and request an online prediction to see the response. So we are going to build today. The sample builds a classification model for predicting income data based on United States Census income data. So if the data is greater than 50K, the income is greater than 50K, so there has to be a label, and if it is less than 50K or equal to 50K, then it will fall to the second category. The sample defines the model using the Keras sequential API. That samples defines the data transformations particular to the census dataset. So for the setup, we'll follow the usual practice, that is to click on the green start button and perform the labs. So let's do this. We'll click on the start lab button and launch with your subscription. Now we'll click on the Open Google Console and enter our student ID and click on Next. We'll copy the password from the documentations page and enter it here and click on Next. We'll accept the terms and conditions and move further. Now finally we are on the GCP. We'll click on the terms of service and agree and continue. Let's see what we have to perform in this lab. We are already here, we have done these steps and we are on the navigation menu of the GC platform. Now we need to launch an AI platform notebooks. So to launch an AI platform notebooks, we have to go to the navigation menu and then navigate to the AI platform and then to the notebooks. So let's go to the navigation menu. Then we have to go to the AI platform. Let's go down and search. Here is the AI platform. And then we need to go to the notebooks. Let's see. On the notebooks instance page, click New Instance. On the notebooks instance page, click on New Instance, or you can click on New Notebooks as well. Then in the Customize Instance menu, select TensorFlow Enterprise and choose the latest version of TensorFlow Enterprise 2.x with LTS without GPUs. So it says that we have to select TensorFlow Enterprise with the latest version, that is 2.6 without GPUs. So the latest in my case would be the 2.31 with LTS. And without GPUs. So now, in the new instance notebook dialog, click the pencil icon to edit the instance properties. Let's see what is the notebook name. Is there a notebook name? There's no notebook name. For the instance name, enter a name of your instance. So let me rename as TensorFlow Sakshi. Now for the region, select US Central 1, and for zone, select a zone within the selected region. If we are selecting US Central 1 as a region, then we'll select the zone as US Central 1A, that is in that region. Now scroll down to the machine configuration and select N1 standard 2 for machine type. For the machine type, we'll select N1 standard 2. Then leave the remaining panes and click create. Click on create. Click open Jupyter Lab. A Jupyter Lab window will open in a new tab. Let this get created and then we shall open it. Okay, so the notebook has now been created and we can finally open it. Let the notebook be created and we get to see a button called Open Jupyter Lab Notebook. By the time, you can always refresh your page and check whether it has been updated or not. Refresh once and check whether it's still loading or not. We need to wait for some time for the Jupyter Lab notebook to be created. It might depend on your internet connection as well. Let's see what we are going to do in this lab. So after the Jupyter Lab notebook has been created, we'll clone the example repository within your AI platform notebooks instances. Sounds cool. It's taking a long time for this to be created. The Jupyter Lab notebook is getting a lot of time. It's taking quite a long time to load. I guess you can refresh it. Yeah, it's there now. We have our open Jupyter Lab, so we'll probably click on that and then on a new tab, a notebook is going to open. So as it says, click on open Jupyter Lab and the Jupyter Lab window will open in a new tab. It's opening here. Let's see what we have to perform next when it opens. So in the Jupyter Lab, we need to click on the terminal icon to open a new terminal and we'll follow the commands that follow along. So we'll open a terminal and we'll add the command line prompt and we'll type the following command and press enter. So I'll just copy this command and we'll paste it over here. And we'll click on enter. So basically it's cloning a repository. So now, when you have when you are confirmed that you have cloned the repository by double clicking on the training data analyst directory and ensure that you see its contents, you are all fine. So the files for all the Jupyter Notebook based labs throughout this course are available in this directory only. So it is still on 38%. It has to be 100% for it to be completely downloaded or cloned. When it will be finally cloned, you'll get to see a picture or something like this on that page. We are on 99%. Let's see when it comes to 100%. So the cloning has happened and we are ready to start. So now it says that navigate to the example notebook. So for that we need to go to the AI platform notebooks and navigate to the training data analyst and self-paced labs training data analyst, and here we get to see the self-paced labs. Let's see what it says next. And we need to open the AI platform quick start. AI platform quick start. Here it is. And then we'll open the AI platform quick start dot ipynb. We'll open it here. Clear all the cells in the notebook. On the notebook toolbar, navigate to edit, clear all outputs, and then run the cells one by one. That means we need to clear all the cells in the notebook. We'll see where the edit option is. And let's see where clear all option is. Clear all outputs. And then run the cells one by one. So we need to run the selected cells one by one. That means you need to run here. And then when the completion happens, you need to wait for some time for the process to get completed. So we are going to move on with step by step. So we are done. Wait for 2 seconds at least for the data to get processed and to give it output, and then we can move further. Then we'll move ahead. So you see that's saying copying. So we need to wait for some time and then we can probably click on the next. Let this happen, let you get some output, and then we can move further. We'll click on run again. Okay, the output is here. That means we are doing it correctly. If the output is not here, you need to again go back to the previous step and run it again. We'll run it. Now the major command. So it says the second file called model.py defines the input functions and it gives you the output. We'll come back to the next function and create it. Come back, run this step, come back and run the step. So as we are running these steps, it's just not about running them. You need to understand what the code is, what you are getting from it, because the knowledge is very important that you're getting from these hands-on lab. Let's export the Keras export. Now we'll prepare input for the prediction. So we are going to pre-process the raw data from the adult.test.csv file and we'll check the numerical expectations. I guess we missed on this step, so that's why there's a warning. I guess we need to define a signature over here. Okay, we don't need to, I guess. Okay, the task completion says from step 3.1 we have to be very careful. We are not at all at 3.1. Okay, so we can perfectly move. Let's keep moving until there is an error. So now here it says replace with your project name. So our current project name is this. We'll copy this from here, or you can copy it from the details panel, and we'll place it over here. Okay. So now we are going to add the semicolons also. We were not supposed to remove that, and we can successfully now run it. We'll again run this and check if we have done it or not after 3 point. We haven't created a cloud storage bucket, right? Okay, it's in the second step. We'll probably follow the same steps, keep running the code and to set up a cloud storage bucket. Earlier we were doing with the Google Cloud console, but now we are doing it with the Jupyter notebook. Now it says go back to the lab instructions and check your progress by testing the completed task. That you have set up a Google Cloud storage and upload the data files to your cloud storage bucket. Let's see if you have done that. We have successfully set up a cloud storage bucket and we have also uploaded the data files on your cloud storage bucket. Now let's move to this step 3.2 where we will be completing a nest task. Again, we need to run it patiently and follow the instructions that are given to us without missing on it. Now, our job ID. So, what is a job ID? Run a single instance trainer in the cloud. So, replace with a job ID. So, we would have gotten a job ID. Would have got our job ID somewhere. Let's find out. Here is our job ID, that is census 2011. I will copy that and we'll paste it over here in your job ID, and then we are going to run it. The output of the previous one gives the command for the next one. So when you're done, and now let's see, it says to go back to the lab instructions and check whether progress by testing the completed task. So let's see if we have performed it well. ML job is not submitted but not in succeeded state. Please wait a few minutes. That means it is taking time. It is submitted successfully, but it's not having a succeeded rate. Let's wait for some time and let's check it again. Okay, it might get updated in a few minutes. We shall wait for that. By the time we can come here and create an AI platform. Created a AI platform with the name Census, that's the model name. It may, as it says, this may take several minutes to deploy our trained model. When done, you can see a list of your models using the models list command. So let's wait for the time being and let's check if the job is submitted, if the job is in the succeeded state or not. I guess we need to wait a lot for this one. Let's move on. This is also taking some time. So we cannot check this progress because the list is not there. So, okay, this worked fine, but why did this not work fine? I guess we need to perform the step 3.2 once again from the step 3.2. From here, we'll perform the steps one more time and see if everything goes fine with that. Okay, I guess we need to wait a lot for this one. Coming to the step 3.4, we didn't create a version of V1 of your model, right? Yeah, we need to still create it. So let's click on this. It says congratulations. Let's check this one also. As it says, the ML model version is created but not in the ready state. We need to wait for it to be done, and we need to wait for this one also so that we can submit it successfully. Also, if you are facing any kind of issues, you can always go to file and go to edit and clear all your outputs and then run again. So that we have created now, we need to probably start it from the very beginning, and then we can see what's wrong with that. We will keep on running and then we shall find it. Where did we go wrong? We were probably wrong in the 3.3 part. Because it's taking time, I'm doing this. If you are getting this from the one try, then you need not to do it twice. Let's see if there has been some changes. Okay, the task 2 has been completed and the creator version of VI has also been completed. So we have a 100 on 100 score. That means we can definitely end this lab as we have completed all the progress checks and this lab has also been completed. That says congratulations, you have learned how to train a TensorFlow model both locally and on the AI platform. So now it's time to prepare the data protection and to perform predictive both locally and in the cloud AI platform. So we are done with this lab. So you can probably come here, check all the text that we have performed, and will you can also perform this test and understanding part and check the solutions for it. So congratulations, we have completed the successfully one lab, and we have learned how to train a TensorFlow model both locally and on the AI platform, and then how to use your train model for the prediction. So now you can end this lab. As it says, if you're done, we can end this. So we have done all the work that we need to do, and we have also scored 100 on 100. That means we can successfully end this. Click on submit and give a rating to this lab and click on submit again. Now first lab has been done. Let's move on to the second lab. So now if you go back to the GDSC link tree, and we'll see if we have a green tick or not in front of our lab that we just completed. We'll go to the program syllabus, go to track 2, go to the second skill badge and see. Okay, so we have successfully completed the AI platform Quick Start labs. So now our second lab would be the Dataflow Quick Start with Python. That is this one. So we'll be covering this lab. For this lab, the Dataflow Quick Start with Python, we'll be covering this as a second lab for our session 3. So we need to firstly click on Start Labs to create our environment. We launch with a subscription. And open our Google console. Sign in with the credentials provided to us. Copy the password, paste it here, and click on accept. Let's see what we have to do in this lab. After we have signed in, we need to activate the Cloud Shell first. I hope you all must have been familiar with the Cloud Shell and the GCP platform by now, as we have completed many of the labs in the program syllabus. Congratulations to those who have successfully completed their track 1 and have moved forward with track 2. So now we'll activate our Cloud Shell. Let's see what we need to do next. We'll click on continue and list out the active account names with this command. Let's click on continue. Your Cloud Shell machine might take some time as it is dependent on your internet connection. So kindly be patient. So now let's see all the active account names with this command, that is gcloud auth list. Click to authorize. and we have our student ID that is running with this command. Okay, so now we'll list the project ID with this command, gcloud config list project, and it says our project ID. Our project ID is unique for all the labs you perform. Now we'll go to the navigation menu, click on IAM and admin, and then on IAM. Then we need to confirm that the default compute service account project number at Itna is present and the editor role has assigned. The account prefix is the project number. Now you can find on navigation menu and home. So let's see the project number has the editor role or not. This is our project number and it has been assigned as a editor role. Works fine. Now, if the account is not present in IAM, does not have the editor role, follow the steps. Copy the project number, example this, and then you can move forward. If you don't, if you're not sure, you can always go to navigation menu in home to check for your project number. Now, on the navigation menu, click IAM and admin, and on the IAM page, click add for the new members type. Then replace project number with your project number. So we'll probably need to see where the project number is. The project number is usually associated here somewhere. Okay, let's see where my project number is. So let's see the project number. For that we need to go on the home page and copy our project number, that is this one. Your project number might be different, so please go ahead with that. And then we need to go to the IAM and admin page and add it. We need to paste this, then we need to copy this and for the new members. We need to probably have this one over here like this. Perfect. With compute at developer.gserviceaccount.com. Okay, so now for role, select the project or the basic and the editor, then click on save. Role, select project. Okay, so we need to manually search it out for the project and then we'll go with editor and then we'll click on save. It's not getting saved. Okay, let's cancel this, then add once more. Okay, so it has already been there, so we don't need to do it again. Now to create a cloud storage bucket, in the cloud storage, navigate to the navigation menu, storage and create a bucket. Here we'll create a bucket. We were on 04257. They have been signed out. So this might happen with you also. Need not worry. You can always sign in back as you have not entered the lab, so you won't be getting a new credential. Confirm. Let's create a bucket, a unique bucket name. So we can probably use GDSC2 as a bucket name and continue. For the location type, we need to select region and US Central 1. And then click on create. And let's check if we have successfully created a cloud storage bucket or not. Let's check our progress, and we have completed it with the name GDSC2. So now we are going to run the Python on the Cloud Shell. Let your Cloud Shell be connected, and then we'll see the Python version that we're on. We are on 3.7.3. Now we'll install pip by using the next command, that is pip3 version. After the installation check, there we have pip install version 7.0.0 on new year. Let's update it to that. And if you won't have a virtual environment set up, then we'll install it by running this. As it says, we don't have, so we need to install it. By the time it's installing, we need to configure a virtual environment in a directory tree containing its own Python distribution. We'll copy this command and use it over here. Activate the source. And install the pip Apache Beam GCP. You'll see some warnings, but it's safe to ignore them for this lab. Okay. So now it says that you installed Google Cloud Dataflow but are executing word count with Apache Beam. So the reason for this is that the Cloud Dataflow is a distribution of Apache Beam. That's really informative. Okay, it's done now. We'll see the output file. So we're going to get a same message, but we need to list the commands. For that we use ls. Then we'll copy the name of the output file and cat into it. So for the file name, we need to copy which file name? Copy the name of the output file and cat into it. So the output file is this one. So we'll cat and paste it over here and we'll cat into it. Your results show each word in the file and how many times it appears. Now set the bucket environment to the bucket you created earlier. Let's do it. Okay, so we need to provide the bucket name. That was for me, it was GDSC2. For you, it might be different. Enter your bucket details. Now you will run the word count.py example remotely. Let's see what happens. Okay, we are getting this output. We're getting this output. So that means that we have done it very successfully. The job message detailed that the workers have stated successfully. Let's see if we get the similar output or not. So we need to wait. Then we shall continue with our lab. Okay, there has been an error. We don't exactly see the problem. There has been a problem. Please ensure the Dataflow API is enabled for your project. Okay, so the Dataflow API is not enabled. So we can go to the APIs in service and enable the Dataflow API. Click on APIs enabled in services. Search for Dataflow and let's see if it is enabled or not. Okay, this has been enabled. Let's run the command once again and see what happens. Because otherwise it's going to create a lot of fuss for you when you move further with the commands. Until then, let's see, navigate to Dataflow from here. You should see a word count job with the status running at first. Okay, the second one is running, as you can see. Click on the name to watch the progress. When all the boxes are checked off, you can continue watching the logs in the Cloud Shell. The process complete when the status is succeeded. Okay. Let's refresh this and check. Let's see if we have done it successfully or not. Job has been submitted but is not in the job state done. Okay. We'll refresh it again. As you can already see that it's in the running state. Your job is in the running state. So we need to wait for this to happen. So now we have this message that says job message detailed, workers have stated successfully. That means this particular thing we have got, so we can continue with the lab. So let's see if we are done with this also. Still in progress. We need to wait. It is still in the running state. It's taking a lot of time. Let's see what we need to do next by moving forward until then. So this is the only progress check I'm supposing. So we need to click on storage after we are done with this particular check my progress. We need to click on storage, then we'll click on the names of the bucket. In the bucket you should see the results and the staging directories. Click on the results folder and you see the output files that your job has been created. Okay, so let's wait for the job state done. It's taking way too longer. Let's refresh the page. Okay, I feel it's about to end. Let's wait for a few more minutes. Keep a check on the timer so that we don't have to perform it again because it's time consuming. I need to sit here. Okay, so now it says that the job state is in done state. So let's check our progress here. The assessment has finally been completed and we can probably see the results by going onto the storage, then seeing the bucket history. Let's go on storage and see the bucket. You see the results and the staging directories in your bucket. Okay, we have the staging and the results directory. So we have completed this lab also. Congratulations. For now, we'll be ending this lab. And when you have successfully completed and you have a 100 on 100 score on the top right corner, that means you have done it. I need to end this lab. We'll give a rating to this lab and click on submit. Okay, so let's check if we have completed this lab or not by going back to the tracks and seeing if there's a green tick or not in front of this lab. So there's a confirmation that we have successfully completed it. Okay, perfect. We have completed both the labs. That is the AI platform Quick Start and Dataflow Quick Start with Python. So I hope you all enjoyed the session. Make sure you complete these labs by the end of your subscription that is going to expire on 26th or 25th mostly. So make sure you complete both the tracks by that time. In case you have any queries, you can reach out to me today at 6 p.m. On Google Meet. The link for the meet will be provided to you in the live chat of this session only. So please give a check, and if you have any queries, feel free to reach out to me. Thanks for watching the session. I hope you all enjoyed. We'll meet next Tuesday with some more hands-on lab and some more knowledge for you to get started with your GCP journey. Until then, thanks a lot for watching the session. I'm signing off. Take care. Bye-bye.